Hello guys, and welcome to today's tutorial on bridge design. Today we are going to do a simple bridge design of a 20 meter span bridge. So I'll just open my robot file, and the first thing most people forget is usually the job preferences. So usually go to your job preference, just make sure all systems are in order. Still, I'm going to use 335. I'm going to change it to the local system. That one will remain that. That's concrete C35, aluminium, timber, database. Okay. Connection RC DS8110. Okay, in essence, you have to make sure that your work template is usually in order. Now, we are going to do the grid system, and I'll start by sketching the grid system for the bridge cross section. So I'll go make it value, add. This is an 8.5 meter wide bridge, add that, and then I'm going to sketch the pedestrian walkway. It's 1 meter wide and 1 meter on the other side. Okay, I'm going to apply that. Then I'm going to sketch for the deck span. Then I'll apply that. Check your grid system. We have the deck system. Currently we haven't sketched for the girders. This is a concrete deck with concrete beams. So from the edge of the deck to the first girder, we are going to have a spacing of 0.95, and from girder spacing will be 2.2. And add, apply, close. There you go. And that is our deck system. Now the next process we are going to do is sketch for the deck itself. The concrete deck, panels, apply, close. So you can see the properties are not well defined. So the first thing we usually go to FE thickness, create new 200, yes, blah blah blah, C35, okay, add and close. Okay, so as you can see, I already created some, but this is just a duplicate system, so you'll have to use this since I showed you how to create it. Then you apply, close. Now when you click into the properties, you see C35, RC shells, all those analysis. Now the next thing you're going to do is check for the local system. As you can see, this local system and the global coordinates are not well in order. You can see the x-axis and the y-axis are opposite. So in this case, we're going to change its direction. That's it. There you go. So the global and the local are all in order. Next, we are going to sketch for the RC beams. So we'll come here, go to RC beams, click for this. I must select that. Our bridge beams are going to be 1130. They're going to be 450 millimeters wide. Sorry. Add, close, and I'm going to sketch them up. Alright. Okay, this pedestrian walkway, this is our girder. There we go. You have your deck systems. But sometimes, as you can see, the deck system are not, they're all center line, but you need it offset downwards. So what you'll do, but first, before you go into that, you're going to put the system one end. You're going to have simple support. On the other, we are going to have fixed support. Six, 4, 2, 8. Close. There you go. That's our deck system. But still, we haven't resolved for this. So what I'm going to do, I'll come here. We have our beams. Go to the upper flange. There you go. Perfect. Okay, now you have to go forward. Okay. Now the next thing we are going to start on now is to produce for the load cases. So load types, dead load, that will be for the dead load itself. We're going to have superimposed dead load. Superimposed dead load. Those are the area load. I'll also have live load, that should be HAUDL. Let me call that on line 1. And I'll also have the same. Okay. HAUDL line 2. And I'll also have pedestrian load. Add. As for the moving load, that's HB and KL. That ones will add it in the as special loads. That's here. We'll add it here, moving loads. But we'll come into that. So let's go to dead load 1. That should be the self weight. As you can see, it glows red, showing that our system is in place. Next, we are going to superimpose dead loads. And superimpose dead loads, we are going to start with 60 millimeters thick asphalt overlay plus railing. So we are going to start with an overlay of 60 millimeters thick asphalt. That will be 0.2. If I go to calculator, a thickness of 0.06 times a density of asphalt, that's 1.44. So we come to loads, load definitions, surface loads. Sorry, can you use this? It is 1.44. Contour definitions. Superimpose dead loads. Again, go there. Come here. Let's go. That's for the asphalt. We are going to also have guardrail. Our guardrail are going to be 1.2 kilonewtons per meter run. So for this, negative 1 plus 2. Okay. I'll also do it for this other side. Then close. Okay. Next, this is superimpose. We are going to have HAUDL on lane 1, and HAUDL on lane 1 is usually given by a formula on BS 5400, part 2 of the year 2006, clause 6.2.1. You can also see it in table 13, and is usually given by a formula HA is equals to 336 into 1 over L, close the bracket, to the power of 0.67. In our case, our length is 20, so that is going to be 1 divided by 20 to the power 0.67 times 36. 36. Okay. That will give you, that gives me 45.15. So H in lane 1, I'm going to have it on there, but I need a center of 8.5, so plus 25. Okay, so we apply the lane load definition. This will be side 1, and this will be side 2. Surface then we'll apply these loads. Then 2. There you go, guys. So we have defined dead load, we've defined superimposed dead loads, we've defined HA lane 1 and lane 2, and now we go into pedestrian loads. And pedestrian loads is defined in BS 5400 part 2 of year 2006, clause 7.1, and in this case our pedestrian load is 5 kilonewtons per meter square meter. So in this case, load definition, surface, There you go. Now we are going to define for the moving load. Before we define for the moving load, we are going to define the center line of each lane in order to apply those moving load. So that will be, okay, that will be 6.5 divided by 4. So the center line of lane 1 is 2.6. 625 and there you go. Lane 1, do we have it at here and at this point. Now can clear the mesh. There you go. Now we are going to define for our first moving load. The moving load is going to be 30 units of moving load. So we go here, this 5400, everything is predefined, which has a point load of 75 kilonewtons. This HB load that you are going to define is this is usually given by, okay, for 30 units, usually multiply 30 units, and 1 unit is 10 kilonewtons. 10 kilonewtons by quick system. 300 divided by 4, that gives you 75 kilonewtons per wheel load. So you add, then you close. So I'm going to name it HB 30 units on lane 1. Then I'll define the lane, this being our lane 1. Define the polyline, and then pick that polyline, then you apply. Okay, next we're going to apply it in lane 2. So when you click on the lane that you applied, it will glow green, showing that the load had been picked into those lanes. Next, we are going to define for KEL, that's the moving knife edge load, and for that we'll come change it to knife edge. Okay, so it's predefined, 120 units UDL, and close. And KEL. This is million 1, so I'll pick it. Okay, 6, define 6, apply. Then for the line 2, there you go. So all our loads being in order. Okay, there's an issue with this one. I'll just show you how to delete loads that are not placed correctly. The pedestrian load, I'm sorry guys, I did this mistake. So pedestrian loads, now we have pedestrian load well placed. I'm sorry about the mishap. You can never always see the moving loads until you've calculated.